Good evening. Welcome. I have a stream tonight. Yay. All right. Unfortunately, I'm running low on solder, so yeah, I'm not going to be soldering much. And no, you might see that I put sockets on the x0xb0x box, but well, I guess that is one reason why I ran out of solders. I went ahead and did these sockets because I forgot to order 14 pin sockets of the good kind. So I decided to off stream very carefully use the not so good ones that like to melt. I did that off stream very carefully so that I did not rush, and I successfully soldered those on. So I have a couple things though that need to be done for the x0xb0x build before I can solder. And we will get to those in due time. Actually, it looks like my audio might be peaking a little bit. Let me check here. Let me try that. All right. Well, that's... Hold on. Let me... try that. Okay, how's that? Okay, I'm not peaking quite as bad. All right, that's... Oh, that actually didn't help any. Lovely. Okay, well, I'll set that back to the way it was, and I will fix this another way. All right, that was there, and... there we go. Nope. Okay, so, well, that's a little too much. And that's a little too much still. Okay, that should be good. Hopefully I am not peaking too badly, because that can lead to weird things. And I don't think that completely helped. Well, I'm trying a new microphone. Maybe I'll just break down and buy another microphone for the basement so that I don't have to carry my microphone back and forth. Anyways, so the first thing I wanted to do tonight is pull out a cool project that I built in the previous stream that was not behaving correctly. Oh, but first, I just realized, in my haste to start the stream, I forgot one important item here. So let me open up a new browser window. Move that to my primary screen. And let's see, move this OBS window over. And look through opaque objects in front of the monitor. And we'll go to the current stream on YouTube. And hopefully it does not autoplay. Good. There we go. Now I can see all the chats because Jay doesn't like it when I ignore the YouTube chat. And yes, thank you, Avast Anti-Track. I'm sure that YouTube is probably still going to track me even though you blocked its tracking attempts, because I am logged into my YouTube account, because you cannot stream without that. And that is okay. YouTube can track me that I am currently live streaming. All right. Oh, yes. You might notice that I actually, well, I got to do something with the cables so that they're not in the way, but I actually have set up my scopes. So if I need them, I can call them up on screen, and I can just as quickly hide them. And when I get a moment, I am going to move my bubble over to the other side of the screen, because seemingly, since I'm right-handed, I am more likely to be soldering over on the same side that my head is on. So that was probably a fail on my part, and I will fix it as soon as I get a chance to drag things over in OBS. I may even make my window a little bigger. I'm actually slowly probably reworking the entire overlay I'm using downstairs, one screen and one part at a time. Because you could probably see with my meters view, I didn't even try to put the little fancy schmancy border around, because, well, they're meters. They're fancy on their own. I can turn them on. And, well, okay, my multimeter is a bit hard to see on screen. I need to go get my, I need to put something anti-reflective down on the table below the multimeter, and then hopefully it will be a little easier to read. But hey, look, I have meters, and I can pull them up, and I can hide them almost just as quickly. So anyways, the problem with the MintySynth is that the amber LED is defective. So I, like any reasonable person browsing Amazon would do, because I didn't want to pay $10 shipping from a distributor for amber LEDs, I ordered a whole bunch of LEDs. Because I have plenty of 5mm LEDs. I didn't have any 3mm LEDs. So I now have, I've got red, I got yellow, I've got blue, I've got green, and I even have some mystery color, which maybe we'll figure out what it is. Because I've got my handheld multimeter that has a diode test mode. Because, oh, my fancy multimeter also has a diode test mode. But this is the meter I was using for the MintySynth, so we'll go with it. So anyways, I believe if I very carefully check the LED here, I don't know which one's which, so, oh, it's a white LED. I should have known. Cool. Okay, so the slightly longer lead on these is positive. So if I take one of the yellow LEDs, which will be an acceptable substitute for amber. Oh, it is amber. There we go. As you can see, it actually lights up. So I know I have a good amber LED, because when I tested the diode or the LEDs on this MintySynth with my meter, the red one will glow, but the yellow one did not, even though they both showed a appropriate voltage drop, which is what the display shows. But as I surmise, while it had a voltage drop that was correct for the type LED, it was not, I guess the LED, it wasn't enough for the LED to actually light up, because apparently its glowy part was defective. So anyways, now I have confirmed that I have a working amber LED, because I would hate to solder another defective LED on this board. Alright, so the LED is these two pins here. I have my trusty engineer solder sucker that makes a really cool sound when you activate it. I have Gootwick, because I may need that. I have the Amtech flux, which I will apply a little to the board. I think a little of this goes a long way. I have my trusty Hacko, which actually, I will try the temperature I have it set to. I have my smoke absorber, because safety. And I've got my safety glasses on. I am going to try the temperature I have this iron set to, which is not the recommended temperature for the solder I used on this, but should be an okay temperature. Make sure I have nothing in the way. Let me hold this at a little better angle for me. And all right. Looks like I need another attempt at all right, and that might actually be free, maybe. Well, actually, it looks like I do need to wick it a little bit. And apparently I want to really get the wick stuck to the board. Or actually, I think it's stuck to the leg of the LED. Oh! I was melting the solder wick case. Alright, let's see if that LED will come out. It does look like there is still just a bit of solder. So I will try the solder sucker one last time. Yeah, I'm probably off the screen. I'm trying to absorb more smoke than it wants to. All right. Well, I guess I will wick a little more, and if I get really desperate, I will go grab my some tools to aid in part removal. Okay. That part is being especially stubborn. Therefore, I will... Oh! That's right. I just set them over on the table that is now beside me. Alright, so... pick some pliers. And no, I just had this brilliant idea of removing the alkaline batteries from the board. There we go. All right. Oh, this might be where I need to. This might be where I need a little extra heat. Oh, hey, Toby. Oh, yeah, okay. Maybe I'm regretting my microphone change. I may just have to break down and go. Is it better with the smoke absorber off? Wow, I'm still picking up a lot of background noise. Is it better now? Oh, okay, well, I can tell you why it's worse. Because my Yeti mic is... I had my Yeti mic on the desk last time. I thought I could get away with not. Oh. Well, I think this. Okay. Probably I will take a break as soon as I fix this board, and I'll go get my Yeti mic. But let me fix this board first, and then I will do the microphone swap. Okay. Yeah, so yeah, we will fix that as soon as I get this board fixed. So I didn't upgrade my soldering table to have lousy audio. Although this is truly a lousy pair of pliers. Let's see here. There we go. That one's got teeth on it. That'll help me. This is... Okay, that's... Okay, well, we will have to do this. Oh, that's weird. All right, let's see if that's out. Oh, needs a little more desoldering. All right, well. All right. That's weird. Come on, through. Oh. Oh, that's just weird. Oh, well. Oh, well, I broke that LED. Let's try another one. Okay. Well, I'm not going to be able to insert the LED as far as I want. Well, there we go. There we go. That'll work. Do one last check, make sure the LED's still functional after that, and that I didn't break it. Like I just did. Oh, okay, that's positive. Did I put it in? I might have put it in backwards. Imagine that. All right, just double checking. That it's in right, because all right, it is in right. All right. I think I may have left the MintySynth on by accident. Yeah, that's a dead battery. Yeah, it's a not quite as dead battery. Well, I'm going to do a twofer. I'm going to go upstairs and I'm going to grab some batteries and I'm going to grab a microphone. So stick around. I'll get some better audio as soon as I figure out where to attach the microphone to, but well, one problem at a time. So stick around, Toby, and hopefully the audio will be improved in a few minutes. All right, if that's not improved, then I don't know. Yeah, that better be better. That is my Yeti caster. All right. And I have batteries too. All right. That looks correct. Oh. Actually, they do have to point that out in the programming manual because apparently one of the earlier versions of this did blink both LEDs in one of the modes. Let's confirm. I've successfully changed. All right. I see audio coming in the line in. That must mean that it works. I think if we turn it off and back on, then you probably hear whatever plays in that mode. Yay! The LED's fixed. And I have about 97 more assorted LEDs to use in the future. All right. So next, I think I'll probably 3D print or something, a little cable holder to keep that cable from sliding backwards. All right. Yes, I was kind of going to reveal. So, yes, this is my new improved soldering station setup. I thought I would reveal it on stream tonight. So I have not one table, but I have 3 tables. So, and of course, not pictured is the Blue Yeti microphone that it's like the one Steve and Joe and Bruce has, except mine's not an Amscope, it's a Vision Scientific. So, but yeah, now I can actually have a table for soldering because the problem was the microscope. The reason why I hardly ever pulled it out, especially not on stream, is because it was on the same table as all my other soldering stuff. And you can see I have an overhead camera rig. The other thing is I ordered a longer, they make a 42-inch bar for the overhead rig I'm using. So I ordered it this weekend and then stumbled upon the parts they accidentally sent me last month when I'd ordered just the camera, the metal brackets that the cameras go on. It didn't dawn on me to measure them first. It turns out that the what I thought was just the standard size overhead piece that they sent by accident because they sent the wrong overhead part. They actually sent me the 42-inch long one. So, oops. Um, anyways, um, yeah, I guess I'll have some extra bars for whatever. I would like to set one of these up upstairs for if I do like a computer repair, a computer upgrade or repair that doesn't require soldering. So I guess the nice thing is I'll have an extra 42-inch bar. So, and then, um, but the thing is, the microscope's on a separate table now. So now, when I need it, I can just slide it over. I may, yep, it'll just slide over. You can't see that I just slid it over, but now it's at least on the table, over kind of in the corner. But I can, if I'm planning on doing a stream where I need to use the microscope a lot, I'll probably move where I have the camera that's pointed at me, or I'll just forego that camera view. Uh, because without moving the microscope onto my primary table, yeah, this is about the view you would see in my head if I'm looking in the microscope, which was probably the back of my head. So, but that's nice. And now that it's off on that separate table, if I'm doing something that's through hole and I don't need it, it just kind of stays off to the side. And well, I guess there's the other view. So the TV on the end, I may mount it on the other side here. That's basically so if I'm working and not streaming, I can play videos. um, it's also hooked up to my Blackmagic capture card, but I don't have any. I don't have that in use at the moment. And then I think, or I thought I had. Oh yeah, just a close up. So there's the meters I have, and I have a word to the wise. OBS does not like it when you have multiple cameras that have the same name. It gets confused all the time. But anyways, I got a camera. It's pointed at the oscilloscope and my precision multimeter, so I can show those on stream. Oh yeah, that is a nice scope. I bought it from Circuit Specialists. I think there is a Micro Center that is close to me, but I'd have to drive to the DC area. No, thank you. I don't like driving in the DC area. Okay, so the next thing I'm going to do is, because there are a couple things I have to do for the Zoxbox. Hey, Trina! Welcome to the stream. You made it just in time to miss the fact that I showed off my new streaming area in the basement. New, old. Basically, I've got more tables, so I have enough space to actually feel like I can work now. And the most important thing is, both of, as you might have seen from, oh, I guess I could pull those pictures back up. Let's see, where were those pictures? Yes, most importantly for stream, I can actually see both monitors very easily now. Because they're now both in front of me. Before, as you can see in the very edge over here, I had a table. Oh, okay. So you did see that. But yes, now I've got both monitors in front of me. So not only do I have the view that you don't see right now, which is OBS and the YouTube chat, but now I'm not like leaning over this way to see the other monitor. So they're both mounted right in front of me. So yay. It makes it a lot easier to see what's going on. And plus I can pull up manuals for whatever I'm working on. So there are a couple things I need to do before I solder the Zox box some more. I kind of wanted to work on it tonight until I realized that that is all the solder I have left. I need to order more. I forgot to do that. So anyways, I will be placing another order from Amazon tonight as well. I'll probably have the solder Saturday if I order it soon enough. Because that they might even have in stock at the closest distribution center to me. So I may actually have a chance of getting it Saturday. Anyways, the other things I need to do for the Zox box are I need to do some transistor testing because there are 3 of the transistors that really will benefit from having a higher beta value than the others. I think basically it's the gain of the transistor. So but I was going to take the opportunity to test all of these transistors because of how I bought them before I solder them onto the board. I kind of wanted to make sure they were good because I did not buy them from traditional electronics distributors. These came from an eBay auction I won. So, because if they're not good, I want to use as many of the original spec transistors as I can, but then I've got some pin compatible replacements because some of the transistors, it just needs to be a transistor. And if I use a pin compatible one that's equivalent, then no big deal. But some of these transistors, such as for Q10, Q9, and Q8, as the website is talking about here, those are going to have more of effect on the sound. So I want to try to use these original transistors. So I have also from eBay one of these wonderful component testers. And basically, all I need to do to test these is take one of these. It doesn't really matter. I just need to make sure I have it in pins 1, 2, and 3. Press the button. And there we go. It is a PNP transistor, which is correct. Because this is the 2SA733P. I believe these are Fairchild semiconductor parts. And the important thing is here is this HFE value. And I am ideally looking for 3 of these that are above 300. But I will sort out the highest 3. And for this, I probably should write the numbers down. I'll pick the highest 3. No, they came from an auction probably from someone who was going to build a Zox box for themselves. They acquired some of the parts and then gave up. So I don't know where they came from. That person may have bought them from, I don't know. They may have had some of the parts. They may have ordered them from UT Source. They may have had a friend that worked in the audio industry and happened to have these, because I think these might have been more used in audio, or they may have just come from a random place on from China. And well, all right. So we'll call this one. It's in the like 250 to, because it was 261. Now it's reading 253. I'll kind of. I'll kind of put them in groups and then go from there. So I'll call that one, it's 250. I'm looking for the highest three. So I'm just going to put them in. I've got numbers written beside me: 250, 275, 300, and 325. And I'll take two readings. That one's 271. $268. So I'll kind of set it down closer to the 275. Wish this thing had a power button. I don't like pulling components out while it's powered. Although, quite honestly, I don't think it's applying power to the component after it's tested it. And if none of these are above 300, I've got some other 733s. There's a 287. 284. Okay. I'll kind of set that down. Ooh. Okay. That one's pretty low. That one's definitely not going to be one of the best three. Ooh, there we go. 318. 315. All right. So that is and one of the reasons I need to do this is because I believe one of these transistors is in the next section of the board I need to solder. That's 286. 284. All right, so that one's about with that one. And yeah, from what I've read, this is actually not unusual for these particular transistors, that some of them are, there's a lot of variability. All right. Okay. There's another one that's above 300. Well, I've got two more of these. Otherwise, I'll go over to the box and grab the other 733s. That one's about 280. And $262. Hmm. Well, all right. I knew they weren't all going to be winners, but I was hoping to get three that were above 300. All right. Next, I'm going to go ahead and test some other transistors. So these are two transistors here. Or they might be... I think they're transistors or MOSFETs. So these, I just want to make sure they're good, because these are harder to come by. I definitely don't want to solder these if they're not good. Ah, they're FETs. Not Boba Fett's, just FETs. So, okay. I do believe that is an indication that that one's good, because that is a 2SK30AY. And this one is a very close sounding 2SK30AO. And yes, that last was an O, not a 0. Hey, Jay. Ah, and that's an NPN. Okay, well, they're both good. I thought they were the same type of component, but they might be. Anyways, those two are some of the harder to source parts. They do appear to be good, so that's a relief. I would have been sad if I had to go to a pin-compatible replacement. And then these are some 2SC536Fs. And I can't tell who made them, because I don't see a manufacturing mark. Unlike the 733Ps where I can see their Fairchild semiconductor, I don't. These are NPN transistors. I'm pretty sure that's correct, that these are NPNs. I don't need to gain test these. I just want to make sure they work before I start using them. Although what I may do is... Okay, some of these have... if I were designing an audio circuit, I think I would want transistors that behave more consistently. At least they work. I'll just test a few of these because I only need... Well, let me pull the sheet of paper out that tells me how many I need. See if I can move these other transistors without desorting them. That would be a shame. There we go. So I need, for the next section, four of these. And, oh, I don't think I even looked at the screen. Okay. And as far as I know, so I'll know the ones I tested because the legs are bent. I don't think there was any reason to gain test those transistors. No, none of the upgrades need those to be gain tested. All right, so I do have four of those that work. Which is good. The A, Y, I think that's the one that worked, which is good. Yeah, there was one other component that I'd like to test, but it'd be really weird to test in this tester because it's a matched pair transistor. And the way the pins are configured on this tester, well, it would be really hard to test. So I would like to find, let me go get my other 733 keys. They're just over in this box. Oh, hi, Burrow. Welcome to the stream. So, okay, there's no transistors in there. So I've got just a few more orders that had transistors in them. Oh, that's really helpful, UT Source. There's the label that should have been probably stuck to the components that I ordered. All right. So, okay. This order did not contain anything that is a 733. These were for some of the other transistors I was worried about. But looks like I don't need to worry about those. Let's see here. Oh, those are some. Now, what are these? Probably help. So I have plenty of potentials to find a. Oh, that is a. Oh, that's one of the other transistors that this uses. Okay. I was not going to test all the transistors. I was just wanting to make sure I had enough for the board that I'm working on. Although I would like to know if either of these are compatible. I would like to find another one that's above 300. Anyways, so this is one of the 732SA 733P transistors that I know is correct. And I have two potential sources of what are probably, I don't know that they should be compatible. I think because they're also 733s, and I think they have the same pin out. They're just a slightly different part number. They should be PNP transistors. So one of these are 2SA 733Ps that are on a tape reel, and they came from UT Source. And kind of a weird tape reel. It's more like cardboard, but well, whatever. I don't want to read too much into that. The other is these are on semiconductor to KSA 733 CGBU. So I think these are should be a modern pin compatible PNP transistor. So these, I have no doubt, work, because I've ordered these from Mouser. The jotting the pin out because I have no interest in reworking the board to make other transistors work. So these on semiconductor parts are, make sure they are actually, I mean, I'm pretty sure these are compatible. Yep. Pin 1's the emitter, pin 2's the collector, pin 3 is the base. That is PNP. So there's potential I can find a third high beta transistor from those. And then these are the UT Source cut reel transistors. Wow, they are really stuck to the tape. Yeah, it is possible. These are actually for old stock. Pin 1 emitter, pin 2 collector, pin 3 base. All right. So those appear to be also potential. I also like the pin spacing of these because I think these are actually oh yeah. Those will actually just fit right into the board. After you get the really stuck on tape off the transistor. I mean, um, I'm not, I have never seen tape and reel components like this. I don't know if that's because these are like new old stock and that's, they really did use cardboard back in the day, or if that's a sign that someone put these on a new tape and it's kind of weird. I mean, they look, I mean, honest, they look fine. It wouldn't surprise me if they are just new old stock. Unfortunately, the getting them off the, well, that one's almost like I need an ultrasonic cleaner to clean these transistors when I pull them off the tape before I. All right. So those are a possibility. Okay, I am curious. These on semiconductor ones. You know, I could have a gain competition. Which pile of transistors will I find a high gain transistor in first? Will it be the on semiconductors that are probably modern PNP transistors? Probably the current part for the old 733. Or will it be these really annoying to pull off the tape and reel ones? That I don't know who made them because I don't recognize any markings. I don't think they have a manufacturer's mark. Oh, there we go. 320. 315. And the on semiconductor wins the challenge. All right. I have 3 transistors that are gain above 300. Which is what I needed. I am not going through the, I think given what I've seen on these transistors, I could probably, because there's 100 here in this pile, and there's 100 here in this pile, and quite honestly, I don't think I'll do much better than the 320 that I've found. I think I found a 320 and 2 that are about 315, which quite honestly is probably about as good as those transistors will get. Because actually, the only reason I'm doing this is I'm not doing the whole mod. There's a mod. I just want to make sure the transistors are in place in case I want to do the rest of the mod. Because since I'm trying to use the older transistors that are more, I don't know, for what it's using in the circuit, I'm sure that on semiconductor one will be just fine. At least gives me 3 with the gain above 300. I mean, it's a transistor. It's analog. for what it's using it for. Whether it's a new or an old transistor, it will be just fine. Although, while I have the transistor tester out, though, I guess I would like to figure out, there are a few other parts. So, this is the eBay auction. Totally legitimate looking Zoxbox bag. It looks like they had started to collect. These are the rarer parts. I still haven't figured out what this MintySynth chip is. There's an IC that says MintySynth. I probably have to peel the label off to see what chip that is. Okay, that's one of the... Oh, the BA6110. I think that's the headphone amplifier. Alright, these are... Oh, wait a minute. I think I just realized there were some more 733s in this. The eBay auction, because it looks like they were in 2 bags. Yeah. By golly, it's more 733s. And these are Fairchild Semiconductor. And I find it very interesting that there's a white dot on 3 of them. And it looks like they've been tested. Okay. Anyone want to place their bets as to whether these 3 with a white dot on them are, like, high-gain 733s? Oh, if I'd only seen this. That is, what do you know? Okay, that was one of them. I didn't realize there were 2 bags of 733s in this eBay auction. Because the one bag was labeled. It had 733s written on handwritten on a label. This other bag was unlabeled. And I should have probably looked at the markings under a microscope. 300. By golly. I think the person who sold this auction had already... I don't recognize the markings. I don't think I'm the one that marked them. 323. All right. Well, that settles that. I'll use the Fairchild Semiconductor ones. Let's see. This was... I think I'm going to very carefully bring my... okay, that was... Very carefully bring my sorted transistors back over to the main table. That was 309 and... Okay, this one's like borderline 300. All right. Yay. Let's test the rest of these. I bet these are all going to be lower gain. $281. Okay, now these transistors I can tell are like old stock because the legs are slightly tarnished. 271. Or some of them are just ever so mildly tarnished, so someone had these transistors sitting somewhere for a while. 252. Yep, I think I can safely say these are the lower gain ones. 264. I'm going to take these three here. These are my high gain ones. Set those aside before I get them mixed up. I'll see if I have another little baggie for the other two that are like close to high, because I'm going to retest them when I... Oh, here we go. Stick them in here. It's like backups. There we go. Ah, it went in with the microcontroller and the resistor looking things that I'd really like to figure out what they are, because I think they're the PTCs that I need. Yep, 255. $52. Yep. Let's see here. 1K PTC thermistor. Is that what this is? Black, orange, red, black, brown. Ah, well, I'll have to decide if I want to use those or the ones I ordered, because I think those are the PTCs. I can validate that. I just have to look up the expected resistance at room temperature. Yep, these are all the low gain ones. Which is fine. There's plenty of the transistors that this uses that the gain is not as important. But what I'm doing is, well, really very similar to what Intel and AMD and NVIDIA would do when they make a whole wafer of parts, and then they have to bin them out to make the various products. It's just, in my case, this is very simple, because all I'm checking is the gain. Whereas in reality, they're binning for much more than just one parameter. Oh, 323. Yep, let me put that in my bag of the bag of the ones that were the high gain ones. Oh, did that one have a... No, it didn't have a dot on it. Okay. And last but not least, it'll be good to have an extra high gain one in case I mess up. Well, without going through a bag of 100 transistors. 262. Okay. All right. Well, I now definitely have enough 733Ps to do the project. And I've sorted out the high gain ones because I will need one of the high gain ones for the next step. All right, I'm going to take one of these. Cool thing about this tester here is, so I think this is a 1K PTC. Now it's just going to tell me it's a resistor. $1031 ohms. All right, I don't know. Let's see here. 1K PTC at room temperature. Oh, wait. That's... Okay. Yeah, I think these are probably them. Oh, okay. I know how I can do this. Now, I'm not going to touch it with the soldering iron. But I'm going to hold the soldering iron close to it. And that should definitely be hot enough that if this is a PTC, then I should see resistance change. I can't find a table quickly, but... Well, that would... Oh. Oh, that didn't get very warm at all. Well, these are probably the PTCs, but I may use the ones I bought because... All right. So, what was in this box? Oh. that's right. Some of the other transistor types. So I guess some of the other transistors I bought here, this was this box from UT Source that I realized didn't have ones I needed for this go around. Oh, more of those really funny cardboard tape. You know, I think these transistors might have been retaped. Okay, so these are two SK1180. And I think I got these because they were supposedly possibly pin compatible with the, I don't know, an NPN. Okay. Possibly because they're pin compatible with the 2SK30AOs. All right, I'm just going to test one to see if these are actually possibly close to what they say they are. All right, and this is a 2SK30AY, which I think is a PNP. Or maybe it's an NPN. Oh, this may be a... Oh, that's right. This is a FET. Okay. Well, that does test... Okay. Well, they do appear to be what they say they are. I will keep my packing list because there's no tags on the bags. That is the only way I am going to remember what those are. Oh, you know, I could put this label... Oh, there we go. That's more convenient. Put the label on the bag they failed to put a label on. All right. So that gets me one step closer to working on the voltage controlled oscillator. I have high gain 733s, so I can put one in place in the voltage controlled oscillator circuit. I did confirm the other transistors I need to use on this board are good, because I don't know, I honestly don't know where the parts came from. I got them from eBay, but where they came from before that, I don't know. Just trying to keep the parts straight because USC 530. Oh, okay. I'm keeping the parts that go on this next section of the board separate from the parts that I was just testing to make sure they were good parts. Oh. And yeah, that... Oh, well, I need to replace the battery that's in there anyways, so... one of the nuts fell out of it. So, anyways, just, I think I got this off eBay. It's a component tester. I don't remember how much it cost. It was a couple years ago when I bought it, but it's just got a Atmega 328P. I think it's based on an open source design, Or at least I presume it's an open source design. This one came pre-assembled. I got it because it was, well, the board was pre-assembled. I had to put it in the case. It did not come in the case, but it was pre-assembled. That's an Atmega 328P and the components. And I mean, I don't know what precision resistors they used for the voltage dividers and the test circuit, but well, for what I paid for it, it seemed like a decent tester. It's got a nice readable screen. I kind of wish the case design made it easier to change the battery, because I gotta take 4 of the screws loose. Unfortunately, not the one where the nut fell out, because that's one holding the display on. Of course, the wrong one would fall out. For whatever I paid for it, it seems to work pretty decently. It helped me bend the transistors. And the cool thing is, it's not calibrated, but since I measured them all with this tool, I think the important thing is the numbers. It didn't seem to read the same numbers each time, but the important thing is I picked the relative highest ones. And given that the 4 I put in the separated out were ones that measured well above 300, I think those are definitely going to be, I think I can safely say that they do have a gain over 300, which is what the mod that I may do in the future suggested. In order to do the mod, I would yep, I'd have to do one other change, and that is there's a resistor on the I/O board you have to change. But unfortunately, it doesn't say what value to use. So, although if I haven't put the resistor on, I don't remember if that's one of the resistors that's R1. And you would think that yep, R1. I've already attached, but I guess I could desolder it if I really wanted to do the mod. But I was going to start with the high gain transistors, see how that sounded, and if I thought it could use an extra boost using changing the resistor value, then I can desolder that resistor and then maybe find a way to test values before I put a new one in. Or I may actually, I've got some SIP sockets that I set off to the side. I could actually replace that resistor with some sockets, and that would let me change the resistor value until I found one that gave increased resonance sound that I liked. Is actually why I ordered these. That, and there were some of the transistors I think I was going to socket just in case I needed to swap them out. Anyways, so that is going to conclude tonight's stream. I just basically wanted to kind of get closer to the point where I can actually solder the variable voltage controlled oscillator. Because the one other thing I need to do is apparently I need to build a small test circuit so I can actually test the oscillator as I build it. And I'll have to see if I can whip up some parts this weekend to do that. I think I may have what I need to do it. Otherwise, otherwise, I've got a bench power supply over on the shelf there that I don't know if it works or not. Maybe that might be this weekend's project. Let's pull out the bench power supply, see if it works, and if not, get it working, because that would give me the voltage source I need. That'd be all I need. Fancier than what Lady Ada said to use, but hey, that would give me exactly what I need. So, stay tuned. I'm sure I will find something fun to do for Solder Sunday, and if it's pulling out a piece of equipment and seeing if it works and trying to fix it, that may be what I do. So anyways, if you'd like to be notified when I'm streaming next, which currently is tomorrow evening, I don't know what I'm doing tomorrow evening. Oh, I'm probably going to finish what I started last week on my MacBook Air. So I'll do that tomorrow. And Solder Sunday, I'm sure I'll solder something. I'm going to order solder as soon as I'm off stream so that I actually can solder things. So you'll give me a subscribe on YouTube or a follow on Twitch. That way you'll have to ring the bell icon on YouTube. That way you'll be notified when I go live next. And with that, I am going to call this stream to an end. The inaugural stream for my expanded work surface. So take care and have a great night.